Right, good morning, and welcome to Hunting Evasive Vulnerabilities. Do you ever wonder about the vulnerabilities you've missed? Sometimes it may have felt like there was something there just out of your grasp if only you had a few more hours. Whereas other times, I think we're all just happily oblivious. Some vulnerabilities are evasive. They have this knack for hiding from us, and in this session, I'm going to explore how they hide and share with you techniques to find them. Evasive vulnerabilities come in many forms, and sometimes they're really quite simple, and it's what's nearby that makes them hard to find. Have you ever had your attention captured so strongly by something that you missed something else that was basically staring you in the face? This is something I call an attention trap, and it's a bit like when a magician does a magic trick, and they use misdirection to make you focus on something and miss something else that's happening right under your nose. I had an extremely near miss with one of these back in 2011. I was hacking addons.mozilla.org, where Firefox extensions live, and I found multiple inputs on the developer profile page, all vulnerable to stored XSS, but there was a catch, which is every unfiltered input was limited to 10 characters, and there was junk data everywhere, and each input was reflected multiple times in different places. In short, it was a giant mess. And I quickly got half a working payload written, and then I got stuck, because the obvious way of closing this payload off required 11 characters, and I only had 10. And I thought, well, maybe I can try a JavaScript string instead or something, but if I sent a quote, the application just blocked it. And so I spent hour after hour hacking away on this, and eventually I got the following working payload, which converts the multi-line string into a multi-line comment into a single-line comment, and then uses a new line to break out of it. And that worked, and I sent that off to Mozilla, feeling really quite pleased with myself. But then a few hours later, when I'd calmed down slightly, a couple of questions just drifted into my head, which are, why is it that when I send \n, that gets reflected back to me as a raw new line? Isn't that slightly curious? And the other question is, well, why is it that the application seems to block requests with a single quote but not containing any other character? And the answer, of course, is this is also vulnerable to SQL injection. I just almost missed this much more serious vulnerability because I was so focused on the XSS. It was almost like the XSS exploited me. Do you think that's ever happened to you? It's hard to tell, right? You don't really know unless you just luckily find it. But the good news is, if you understand these vulnerabilities and the way they hide, you can start to recognize these dangerous situations and then react to them. So today, I'm going to talk about why these vulnerabilities deserve our special attention, how they hide, where scanning and automation fit into the puzzle and where they don't, and then wrap up and take up to 5 minutes of questions. First off, teeny bit of background. At the end of 2009, I won the first ever Nullcon Capture the Flag, which I'm extremely proud, and decided to call myself Albino Wax for reasons I'm not going to talk about now. And I've been hacking websites ever since. I've spent the majority of that time helping out with Burp Suite, researching new techniques, and also researching old techniques that people weren't paying much attention to. And some of those are quite popular these days, which is really cool. But during this time, I've become increasingly conscious that there's a lot of vulnerabilities in well understood and well documented attack classes that are still missed by most people. Like, I miss these, other people miss these, and scanners definitely miss these. And often, we all miss the same things. Now, plenty of people know that this is the situation, but fewer want to talk about this very much, because you're not going to sell your scanner or your consultancy services talking about all the terrible vulnerabilities that they'll leave in the application after the audit is finished for any hackers who are going to turn up later. So today, I'm not here to share a new attack class or new techniques. Instead, I'm going to tackle two questions. What factors hide regular vulnerabilities and make us miss them? And how can we overcome them? Evasive vulnerabilities have always existed, but they're becoming more important every year because obvious vulnerabilities in high-value targets are dwindling. Because by the time you look at something, chances are it's already been hit with white box scanning, black box scanning, and other manual tests. So all the obvious vulnerabilities are mostly gone. Meanwhile, evasive vulnerabilities mostly don't get found and fixed by definition. So they only get patched by accident, and they just tend to pile up over time. They're also correlated with application complexity, which is increasing. So the raw number of these vulnerabilities that are present is also probably increasing over time. And taken together, that means that the ability to find these vulnerabilities is becoming essential for finding good issues in high-value targets, and it becomes more essential each year. That's the logical reason to care about evasive vulnerabilities. But I'd be lying if I said that's why I care. For me, there's a different reason, and I think this exploit captures it. Some of you might recognize it, but if you don't, enjoy. Here, we've got a two-factor authentication prompt from Authy. They're a third-party auth provider, so providing this kind of prompt is their job. And if you look at this, you might build a kind of mental model for how this system works and think, okay, they're comparing the value I submit with the value they've generated and stored in the database. So maybe I should try SQL injection, right? And SQL injection doesn't work. But Homikov found something that does work. He found you could bypass this prompt on a lot of different websites, all using Authy, by entering /SMS. This is not a complex payload, but it's elegant, it's effective, and unless you have a great knowledge of how that system works, it's really quite surprising too. And I'm interested in evasive vulnerabilities because the world is just a more interesting place with findings like that. So let's make things interesting. In this section, I'll explore different factors that hide vulnerabilities, and I'll illustrate each one with a case study. Every case study is from my personal experience. It's a vulnerability I either almost missed and maybe found due to luck, or one that I did miss and then discovered I'd missed a few years later. I've taken these all from my personal experience because although vulnerability write-ups are a great source of information, it's often hard to learn much about how vulnerabilities hide from them because they're so focused on the vulnerability and not how it was discovered. Because these are from my personal experience, unfortunately they're all about web, but I think they'll be valuable to everyone regardless of what your specialism is, because it's not really about the case studies. They're just there to help communicate concepts which are more universal. To start us off, let's take a look at a really common problem, the highly visible defense. A long time ago, I made a proof of concept for quite a fancy attack against bugzilla.mozilla.org, and it demonstrated that by loading Bugzilla's search page inside an iframe in my victim's browser and repeatedly reloading it and timing how long it took to load, I could extract secret bug contents, which could include Firefox 0 days and other juicy stuff like that. Now, the important thing to know about this proof of concept is that it definitely works. It was quite slow. I think it took about 1 minute to extract one character, but it definitely worked. You gave it time and it would get there and it would get that bug. And so I was quite surprised when I submitted this to Mozilla, and there might be someone in this room who said this actually, and they said, this attack can't possibly work because Bugzilla is protected against this thanks to the X-frame options head. And X-frame options does a great job of stopping people from framing pages, and my attack relied on framing this page. So I thought, well, they must be wrong. That header must just not be present. And I looked, and there it was. X-frame options, same origin. Now, if I'd seen that header, I would have never bothered writing the proof of concept, because I would have never thought that it would have worked. But the thing was, it did. And after a bunch more digging, it turned out one of their back-end servers specified all the headers twice. And then the front end concatenated that into a single header like so. And then when Firefox saw that, and it thought, yes, we should totally be framing this response. That's absolutely fine. So yeah, that was why the proof of concept worked on Firefox, and they patched the backend so it didn't duplicate the headers, and they patched Firefox so it wouldn't treat that response as being frameable. And the crazy thing was, the technique still worked on Opera. I told you this was a long time ago. And it was like, well, how can this possibly work on Opera? This definitely isn't frameable now. And that turned out to be because it was doing the attack successfully by measuring the time it took Opera to display the page that said you're not allowed to display this inside an iframe. So this is an evasive vulnerability, because if you see the defense, you think the defense is going to work, and you don't try the attack. And the way to dodge this kind of issue, it's kind of blunt, but don't look for defenses. Instead, just start with the attack, and then if the attack fails, then it's time to try and figure out why and try and fix it. And if there's a defense that's actually relevant to you, then you'll find it. The impact of visible defenses can be seen even at the scale of entire attack classes. If you pick a niche vulnerability class, there's a fair chance that you'll see a wave pattern in the search interest in it like this. And this has a bunch of causes, absolutely, but one of them is ineffective defenses doing a great job of putting people off trying that idea out. This particular technique was published in '96 under the title Web Spoofing and Internet Con Game, and these days it's more widely known as DNS rebinding. Now, when this was released in '96, it was fairly promptly patched in web browsers via a mechanism called DNS pinning. But the thing is, DNS pinning has never actually worked. It's never actually made it impossible to do this attack. All it's done is it's helped create this crazy wave effect. So in this graph, every peak is someone giving a presentation at a major conference saying DNS pinning doesn't work. You can bypass it, and here's some cool attacks you can do with DNS rebinding. But then after a couple of years, everyone just forgets, and we enter one of these troughs. And in the troughs, every vulnerability in this entire class is evasive, because no one is thinking about this class, no one is talking about it, no one is publishing write-ups using this technique. And I have personal experience of, if you mention this technique in one of those troughs to a tester who's been in the field a while, they may well have heard of it, and they'll say something like, nah, it doesn't really work, it's not practical. Or DNS pinning means that it just doesn't really work, and it's not worth trying it. People will brush it off. Or they'll even say it's too old. And you shouldn't call a vulnerability class too old. This is a terrible thing. What you're doing there is you're conflating it with a bug. If a bug is really old, yeah, it's often not so valuable. But if the vulnerability class is old, it just means there's less other people using it, which is great. It's probably more valuable. This lack of a long-term memory is also why you see techniques getting reinvented repeatedly by people who never knew they existed in the first place. So they think they found something hot and new, and then someone always pops out of the woodwork in the comments and is like, this person documented this 10 years ago. But you can't really blame them, because our overall awareness of techniques fades so fast. And the solution here is, absolutely, seek out old and unfashionable techniques. And I definitely recommend that, but it's not quite that simple, because there's a catch, which is that our understanding of niche techniques degrades, it rots over time, right down to the very definition. You can see this with request mugging. It used to mean causing a desync between a proxy or reverse proxy and the server, thereby compromising random live users' accounts. And yet for a period of about 10 years, that term, the same exact term, was used to mean bypassing WAFs, basically. And it's no wonder that people didn't pay that much attention to it, because that's just not that exciting, right? And you can see the same with HB response splitting. This used to mean injecting headers in the response in order to cause a desync and exploit random live users. And over time, it got corrupted and watered down to basically mean injecting headers in the response in order to get reflected XSS. This is really quite scary, because what it means is, if you hear of this technique and you Google it, well, Google prioritizes the most recently written posts. So what you're going to land on is the most watered down, useless explanation of this technique. and you'll walk away thinking you understand what response splitting is, or what request smuggling is, and you've actually learned something that's far less valuable than the original source. And you can witness this for yourself. Just search for response splitting and sort the results that come up by the date they were written in. And you can see the oldest ones have the most information in about the original meaning, and then they gradually get less useful over time. So this is terrifying because it has a massive suppressing effect on old techniques, because you search for the old technique, you think you understand it, and you think it's this thing that's not that powerful. And the solution is, well, don't rely on search engines so much. Just treat the internet like the labyrinth it was supposed to be. Load up some old posts and click on the hyperlinks, and you'll start finding some really valuable stuff. Try and find the original source for each piece of research, because for each major technique, there's probably a white paper or presentation that someone put a lot of effort into when that was originally made, and a bunch of the information in that original post may well have been lost to overall awareness since. There's actually something else interesting hidden in this graph, which is the fact that nothing happened in 2016. This is really remarkable, because in 2016, Regilero presented the HP request smuggling, the real request smuggling, proper technique at DEF CON with CVEs and multiple live demos. And at the time, you could have just taken that technique and used it to hack a significant portion of the internet. And yet, no one did. And nothing really, there was no real interest in this technique until I presented the same technique 3 years later, which is quite curious. And I think the reason behind this is because it was presented in 2016 as this dangerous and implicitly difficult technique, and that just made us scared of it. When we see this, we don't literally think to ourselves, this is scary. We see it, we kind of feel scared, and then we justify why we shouldn't do it to ourselves. So we tell ourselves, that technique sounds cool, but it's not practical, or it's too difficult, or it's too dangerous, or I don't know where to start. And the reason that I know this is because that's exactly what I did the first time I saw that presentation, and then eventually I realized I recognized the excuses I was making were just nonsense. And I tackled it, and I published a presentation that said, actually, it's not that hard, it's only mildly dangerous. And then other people started using it. So this fear of failure affects all of us, and the key to defeating it is to spot these warning thoughts. Just notice when you're thinking them and recognize them for what they really are, which is a sign you should take that technique and give it a go. These days, if someone takes a technique and says this is too dangerous to try in production, my view is do it, prove it. I want to see the evidence. Evasive flaws are often frustrating. And the worst ones are where you come really close to finding them, where you actually have the idea, and then you think, that will never work, and you don't try, and generally you forget about it until 2 years later someone else tries the idea with great success and gets a blackout presentation out of it, and you just feel annoyed. Now, this kind of mistake made me discover an entire attack class 2 years late. I was doing a pen test on a site. There was attacker-controlled data landing in a spreadsheet, which also had sensitive user data in it, and the spreadsheet was getting opened in Excel. And I found if I specified value starting with an equals, Excel would treat this as a formula and evaluate it. And I thought, well, great, I can multiply numbers. I wonder if I can do more with this Excel formula. And I thought, nah, that's never going to work. I'm not going to bother. And then for 2 years, doing pen tests, I ran into this same scenario on different websites over and over until I finally cracked and I had a go. And within a couple of hours, I found I could steal user data as long as the victim clicked on a poisoned cell. I could get arbitrary code execution on Excel after a warning prompt, which was pretty scary but also misleading. Not going into details there. And on LibreOffice and OpenOffice. So at the time I was getting pestered by an intern, and I said, just look at LibreOffice, whatever. And in 2 hours he found you could get code execution on that before the security prompt appeared, which was quite bad. And I published this technique, a few years ago, and I know that this was successful because someone recently tried to hack one of my colleagues by emailing them malware with embedded inside a CSV using this very technique. So to avoid this pitfall, what I try and do now is say that will never work unless, and then I try and specify exactly what scenario would let this technique work. So here I'd say something like, well, I'll never be able to do much damage with a formula in Excel unless desktop spreadsheet software has powerful functionality that can be reached using formulas. And as soon as you say that, it starts to sound slightly more plausible. There's a variation of this mistake, which is to think, okay, that idea might work. That's a great idea. This idea is wonderful, except for one thing, which is it's too obvious. This one happens a lot. And what you're implicitly saying is, this idea will never work, because if it did work, someone else would have already thought of it and tried it and published their findings. And any link in that chain can break, right? A lot of people don't publish their findings, or they do and you don't find them, and so on. But the one that breaks the most is that everyone thinks this technique is too obvious, this idea is too obvious, and nobody tries it. It's the security version of the bystander effect. And to demonstrate it, I'm going to do a teeny bit of research. So let's imagine you found a CSV injection on a major website that offers good payouts for medium severity issues, which is quite a plausible situation. This bug is still everywhere. And, well, which of these 4 payloads are you going to use to get this hypothetical bug bounty? None of them are very good, right? First one has no security impact. The second one could steal user data, but it requires on a user click on a specific cell, which is not that realistic. The third one has a security prompt, and the fourth one is patched. So that's useless. So if only there was a way to steal the other user's data from this spreadsheet silently the moment the spreadsheet was opened, right? If you had something that could do that, well, maybe you could get a decent bounty. And, well, I published this technique 8 years ago, so you might assume that someone would have tried to do this since, right? But using my incredibly poor Windows platform knowledge, in 2 hours reading the Excel documentation, I found I could trigger a pingback over DNS using a teeny bit of syntax like that, and after a couple of hours more, I just wrapped this in a couple of Excel functions and found a way to embed other data from the spreadsheet in this pingback. So with this payload, as soon as the spreadsheet is opened, you've got a DNS pingback going to your server containing the rest of the data in the spreadsheet. And it does, I guess, it looks complex. That's because of the CSV format. The hardest part of writing that payload was escaping the quotes correctly. And I've never shared this payload before, so I hope you find it useful. Maybe get some bounties with it. Why not? I hope there's no one from Microsoft in the audience that cares. But mostly, I hope it shows the point that there's valuable techniques out there that are within your reach. You don't have to put months of time in to find something that is beyond the current state of the art that's valuable. You can just reach out and grab them within a few hours. Of course, some things are not so easy. If you read bug bounty write-ups often, every now and again, you'll find one, often on Facebook, that starts with paragraphs of explanation of business functionality, and it just doesn't make much sense. It's hard to follow, it doesn't seem relevant, and it doesn't contain any vulnerabilities. And then they'll present a really simple-looking exploit and get a massive payout. And I think what's happening here is, although the exploit looks simple, it's actually a kind of exploit chain, but they're not chaining multiple vulnerabilities, they're chaining a large amount of application-specific knowledge with a vulnerability. And this kind of knowledge is non-transferable. It's website-specific. And so you can be an expert at application security, and this post still won't make any sense to you unless you're really familiar with that specific website. And this kind of knowledge is easily underestimated, even though the value is pretty obvious. That's because, although it's valuable, it's also extremely inconvenient. I know this painfully well myself, because whenever I apply novel techniques at scale, they always perform better for other people than they do for me, because I'm not able to make the time commitment to a single website to get this kind of knowledge. My most spectacular example of this was a few years ago. No one was doing variable name, no one was doing parameter name guessing at the time, or no one doing it publicly. And I'd just coded but not released Param Miner, which automated this process and did a pretty good job of it. And I'd also just got an invitation from HackerOne to go to New York and try and hack the US Air Force in a live hacking event. And I was like, great, I'll fly out to New York, I'll run this tool, and I'll make lots of money. This is how I think it's going to play out every single time. So I flew out to New York. I ran the Param Miner. It did a great job. It found loads of parameters that you couldn't otherwise see. And then the whole event was one day, and I just didn't have time to do anything useful with any of the parameters because I didn't even understand how any of these websites worked. And in total, I made $100. And yet, when I'm chatting with people at conferences, they often say, hey, thanks for making Param Miner. That tool found this param that made me so much money. I love it. It works for them because they have this application-specific knowledge. So if you want to see this approach to finding evasive bugs done right, don't look at what I'm doing. Take a look at file descriptors bugs on Twitter and also Orange Size Microsoft Exchange research. These are kind of two ends of the spectrum. If you read them, they look quite different, but I think they're coming from the same source, which is great AppSec knowledge combined with really good knowledge of the specific target. Application-specific knowledge should not be confused with fingerprinting. There's a methodology for finding bugs, and it's simple, popular, and sometimes really quite harmful. I call it the strip kiddie methodology. It's harmful because some things are easy to exploit, but hard to fingerprint. Take web cache poisoning. Let's try and find web cache poisoning using this methodology. And some people do this. This is based on observation of what people really do. They're like, okay, using this methodology, step one is to ask, are they caching? Are you ready? Okay, how do we know if they're caching? Well, maybe they've got a known standard cache header, so let's look for that. Okay, but some use non-standard headers, so let's grep cache header values for keywords like hit and miss. But some don't set any headers at all, so let's use reverse DNS to see if it matches a known vendor like Akamai. But some don't have any headers at all or are findable with reverse DNS, so let's start gathering timing information from responses. But now we've got false positives, so let's start putting in repeats to deal with the false positives. And even then, after doing all this work, all they've done is missed a bunch of caches that can't be successfully, reliably fingerprinted with any of these techniques. And there's a better way, which is don't look for the technology. Look for the behavior that's relevant to what you're trying to do. So actually, if a cache, even if a cache exists, if there's no unkeyed parameters, it's not relevant. To poison a cache, you need an input that affects the response, and it needs to be unkeyed. So get a list of the inputs that affect the response. You could use Param Miner. And then ask for each input, is this in the cache key? And that's, once you've got that initial information, that's really easy to ask. And if you find that, great, you're well on your way to a cache poisoning attack. And this approach sounds like it might require more work than doing the fingerprinting. And I think that's the attractiveness of the fingerprinting. But this entire thing here, prior to the last point, is automated by Param Miner. So, although a reoccurring theme is that the steps that we take to improve it's a reoccurring theme. We take steps to improve our efficiency and we miss vulnerabilities as a result. So we have to be prepared to sacrifice some efficiency if we want to find these cool bugs. But automation can just step in and help us out here. There's an old cliche that security scanning and automation is about finding low-hanging fruit. And this is dangerously misleading because when used correctly, automation puts high-up fruit within our reach by providing a platform that we can stand on. The simplest way it helps is not the most flashy, but it's vulnerabilities that hide just by being inconvenient to test for. This is something I just made up. I'm quite proud of it. It's called the Pyramid of Pain. And it shows the number of manual steps required to test one payload on a given input. The labels are fairly arbitrary, but the size of each layer shows roughly how many probes people are going to bother throwing at that input. Because if testing one payload requires a manual 5-step sequence, you're just going to give up quite quickly. But with automation, you can take this pyramid and flatten it so that every payload you try is as easy as testing a reflected input. You can do this with tools' built-in features. You can do this with user extensions like Stepper and Hackverter and many others. You can do it with tools' lightweight scripting capabilities like macros in Burp and Zest in Zap. And you can do it with your own code, of course. It's just a balance between putting in the minimum effort to get the job done and setting yourself up well for next time. This is absolutely not flashy, but it's valuable because once you flatten this pyramid, you can have proper quality time with the attack surface at the top of the pyramid that everybody else barely glances at. There's a related problem that's even worse, which is attack surface overload. Too much attack surface, too little time. Now, some approaches to testing scale better than others. You've got fully manual testing, does not scale well at all, and fully automated scanning, in theory at least, scales extremely well. And in the middle, you've got combined efforts like using tooling to run a massive word list and then manually reviewing the results to see if there's anything interesting. So on a massive attack surface, a typical approach is great. Do fully manual testing on high-risk functionality and just do fully automated scanning on the rest. And this is not ideal because there's a lot of attack surface that's only looked at by the scanner. And I talk about scanner weaknesses in a lot more detail in a different presentation called /powered scanning. But the really short version is scanners lack intuition, and that means for some vulnerability classes, they have to ask really specific questions like, is this input embedded in a single quoted string within a twig template with no filtering, encoding, or transformations? And if the answer is yes, great, they found that vulnerability. But because these questions are so specific, to get full coverage, they would have to ask millions of questions. I call this the million payload problem, and they can't do that. So they're forced to compromise, and that gives them blind spots that manual testers don't have. There's two things that we can do about this, and the first one is really quite lazy. It's a proper top 10 hacker tricks that blue teams hate. If you're not the first person to look at a target, it's probably already been scanned by someone else with popular scanners with the default settings. And you can afford to miss issues that they would have found. So just take your tool and just flip some random settings. It doesn't really matter what, because then you'll start finding issues that their scanners missed. The second point is a bit more heavyweight. You can dive into the middle of this scale and you can start writing code that asks broader questions. Don't just scan for vulnerabilities, but scan for clues, scan for interesting behavior. If you ask broader questions, like if I send 2 backslashes, does it get reflected back to me as 1? Well, if you see that, there's something interesting happening server-side. It might just be regex injection, or it might be code injection. As a human, you can find out quite quickly. This behavior is quite rare. And similarly, if you send the word null, and that gets a different response consistently from similar strings and from deleting the parameter entirely, then this isn't showing a vulnerability, right? You wouldn't put that in a pen test report, hopefully. But it's a clue, because it's showing you can reach a code path that maybe the developer wasn't expecting you to reach. And the scanner can just find that for you and present it to you. And if you want, you can take that and try and work with it to get a decent bug. Because this is not about diagnosing vulnerabilities, you don't really need to worry about false positives. It's just about using automation to quickly sift through a huge attack surface looking for quirky behavior and breadcrumbs to guide us towards the good stuff. While applying this question-based approach over the years, I've gradually found it's even more powerful than it looks, and it's an evolved version of this that's powered all of my recent research. I call this scanning to learn. The key is, as you get more comfortable with asking broad questions, you'll ask broader and broader questions, and you'll start asking ones where your goal isn't to find a vulnerability or even to find something really suspicious. Instead, it's to learn something that might be useful or to test a hypothesis. And every question you ask like this will inevitably leave you with more questions, but then you can iterate at asking follow-up questions and gradually learning things that nobody else knows. You could call this machine-powered learning, if you like. The machine does the work, you do the learning, but the driving force is your curiosity. For example, this is one research lead I followed, and it didn't turn out well, I'll just tell you that in advance. But while reading the HB2 spec last year, I noticed that there's this pseudo-header called :path, and it's always represented with the string :path. But the HPAC, which is HB2's compression algorithm, maps it to the byte 4. But with HB2, with the protocol, technically you can send a header called :path and just not map it to the byte 4, which creates this slightly ambiguous situation. And I don't know, and it just left me with a question: what happens if I do that? Right? I don't have a specific vulnerability in mind here. There's a number of ways this could go badly, I guess. That's why I'm asking it. But within 10 minutes, I could just write up a teeny bit of code, and then I ran this on a couple of 100,000 websites and looked at the results with no idea what was going to happen. And the answer was, well, they basically all rejected the request. And that left me wondering, well, are they rejecting it because I've hit an exciting code path and things are kind of blowing up and throwing exceptions? Or is it just because they don't like colon at the start of a header name? So I sent a follow-up with :ASDF instead of :path, and they rejected that too. And I was like, well, okay, what's happening here? Is it because they're trying to treat this as a pseudo-header and ASDF is not a valid pseudo-header? So I did a follow-up with a colon just in the middle of the header name. And at this point in time, I realized actually the HPAC library that I was using wasn't doing what I thought it was doing, and the whole thing was a waste of time, and it collapsed in a heap. But you can see you can take this iterative approach to asking questions, and you can gradually learn things that nobody else knows. You'll just start stumbling on bits of knowledge that are not derived from specifications. They're not how things are meant to work, they're how things really work, which is how you can hack things. There's 2 key points to keeping this approach effective. Firstly, it's crucial that asking these kinds of questions is easy, because otherwise you won't ask very many. The reason that this research line collapsed is because for me, patching the HPAC library to do what I wanted just looked like more effort than it was worth. And you don't have to make a framework and so on up front for this. Just each time you ask a question with a bit of code, just ask yourself, how can I make it easier next time? And over time, you'll end up with a framework and a test bed, and you'll reach a point where it's so easy to ask questions, you'll be happy to ask really stupid questions. And as soon as you start asking really stupid questions, you'll start finding some really stupid websites and having a great time. The second point is maybe a little bit hard to visualize without trying it, but if you ask a good question, you'll generally find some obvious interesting things on some sites, and you'll get a lot of noise from others. So you'll naturally want to tweak the code to eliminate the noise. When you make this tweak, you'll have a choice, which is, do you eliminate just that identified noise source, or do you eliminate everything that's not interesting? And here it's really important to just be specific and just eliminate that one noise source, because there are often valuable things hidden in the noise, even if you think that's not possible. It's much better to have 5 scan code change cycles to eliminate 5 different noise sources than to code something that's too broad and lose something that's valuable. The underlying value of this is that every question that you ask is built on your own understanding and assumptions. And if you're really lucky, when you ask this question, you'll get some results that take your assumptions and destroy them. That is pretty much everything I have for you. I hope you found it useful. If you'd like to explore these case studies in more depth, you can grab these slides on the website within a few days and then dive into the references here. There's one final point I'd like to make, which is, it's a mistake to think that there's one true way of doing this. So if anything speaks to you, take that and put your personal spin on it. And if you disagree, take what I said and do the opposite. Maybe you just want to set things on fire. Great, go for it. Where you differ from other people is where you find new issues. If you try and mimic someone else's approach too closely, you're basically a scanner with the default settings. The 3 key things to take away are that there's quality bugs easily within your reach, scan to learn, and that idea you've got, just try it. I'll take 4 minutes of questions now. If you have any more after that, just grab me at the conference or chuck me an email. Don't forget to follow me on Twitter. Thank you for listening.